f of a is less than y is less than f of b. That means there exists a point which is lying between f of a and f of b. It's a continuous function. Then it should have pre-image. That means it cannot leave points between f of a and f of b. Every point lying between f of a and f of b should have pre-image. That means there exists some x naught in AB such that f of x naught is y. Fine. And the third result that we have is if f is a function from 0, 1 to 0, 1, then it has a fixed point. F is a continuous function from 0, 1 to 0, 1. Then there exists some x naught in 0, 1 such that f of x naught is x naught. That means there would exist some fixed point. And then the last part that we have is last theorem, converse of intermediate value theorem, partial converse, not the whole converse, partial converse of IVT, that if f is a function from AB to R, strictly increasing function. It's a strictly increasing function and it has a property that if y lies between f of a and f of b, then there exists some x naught belonging to AB such that f of x naught is y. Then you have that f is continuous function. If f is satisfying such property, or you can say if, in easy language you can say f of I is an interval. If f of AB is an interval, that means image is an interval, then f is continuous. Okay. See, in the last part I am not assuming the function to be continuous. It has intermediate value property and it's a strictly increasing function, then it is continuous. So we'll make use of these 4 theorems to solve each and every problem. And now you have to tell me which theorem should I use to solve each and every problem. One of you has to tell me.
Excuse me. So I had a doubt. Like, is the intermediate value theorem is that only applicable for 0, 1 to 0, 1 or any other intervals too?
For intermediate value theorem, you have general AB, closed and bounded interval.
Okay.
For intermediate value theorem, you have in general AB, not just 0, 1. For fixed point theorem, you require it to be 0.
Sorry, fixed point theorem I was
yes.
meaningful.
For fixed point theorem, you require 0, 1 thing.
So why can't be any other interval for fixed point theorem?
Because the proof requires to be, see, if you have any other interval AB to AB, the proof that we did for this fixed point is we make use of the thing that, so basically we defined a new function which is f of x minus x, right? So now if you consider your g of a as f of a minus a and g of b as f of b minus b, you don't know whether this g of a is greater than 0 or g of b is less than. You want that the sign of these two things should be opposite. right? If it is not 0 1, you are not aware that which is positive or which is negative. Then how will you apply your intermediate value theorem here?
Okay.
Right?
Mhm.
0 should lie between these two values. Then you can apply intermediate value theorem so that it is equal to 0 for some x naught. If it is given to you that if I replace this, I'll do so I'll do this exercise. It's somewhat generalization of this fixed point theorem. This fixed point theorem will become a particular case by this exercise. Let's see. It's a very nice question. See. So now, what do you have is 18.8 exercise. Just 1 second.
This is a IVT.
Yes. Rasmeen? Yes.
Yes, can we solve this using IVT?
Can you solve?
This 18.8 using IVT.
Yes. That's a generalization of 18.8 is a generalization of this fixed point theorem. But you require some more condition for it. Yeah, so the question is, if f is a function from R to R, f is a continuous function from R to R, such that f of A and f of B is less than 0. Okay, so suppose there are 2 points, A and B are 2 points in R, and f of A and f of B is given to be less than 0. So then you have to prove that there exists a root here. There exists some x naught belonging to AB such that f of x naught is 0. Fine. Why this is a generalization of this fixed point theorem? Because now you can really define your function g of x as f of x minus x, but see, here you require that f of A and f of B should be less than 0. So if you are given that g of A and g of B is less than 0, then you have a pre-image for 0 and then you can have a fixed point. Fine. So Atul, did you understand why it is not defined for any, this fixed point theorem is not defined for any general AB? Because you require some more condition also.
In this case, is it the product of f of A and f of B is less than 0, or like individually they're less than 0?
No, product of f of A and f of B, because f of A is a real number, f of B is a real number, so the product of two real number is less than 0. So now you want to prove that there exists a root. That means, suppose this is your continuous function. So first of all, what does this condition mean? That f of A and f of B is less than 0. This means that if the product of two real number is negative, what does that mean? That one of them has to. Yes?
Yeah, no, I was actually saying the same thing.
Yes. One of them has to be negative, right? One of them has to be positive and one of them has to be negative. Either this case, either f of A is less than 0 and f of B is greater than 0, or f of A is greater than 0 and f of B is less than 0, right? These are the two possible cases that can arise. Both cannot have the same sign, because otherwise the product cannot be less than 0. Fine. So we'll deal with the first case. By symmetry, second case will be solved. Okay, so we'll deal with the first case when, suppose this is your A, this is your B, f of A is less than 0, suppose this, and f of B is greater than 0. And it's a continuous function. So by intermediate value theory property, this function has to cut this real line somewhere, right? It is not possible for the function to reach from this point to this point without cutting the x-axis. So did you understand what I'm trying to say? Anyhow you can draw a function, continuous function, this. It has to cut a real line somewhere because it's a continuous function. That is the statement of this theorem. That if you have any continuous function, one point is here, another point is here, and it's a continuous function, so it has to cut this real line. That means it should have some root. Otherwise, the function cannot be continuous. So is the meaning clear of this exercise? What we are trying to prove in this exercise? That if you have a continuous function, it should cut your real lines. If this condition is given to you, that one point is above x-axis and the other point is below x-axis. Now what? Now how we will prove that there exists a point such that f of x naught is. Suppose we are in the first case, f of a is less than 0 is less than f of b. Now what?
The intermediate value theorem.
Yeah, so just apply intermediate value theorem. Since f is a continuous function on whole of R, so you can make it a continuous function from AB, right? You can restrict to your domain, right? If it is continuous on whole of R, it is continuous on closed and bounded interval. Because continuity on whole of R means it's continuous on each and every point of R. So basically it's continuous on R, right? So f is continuous from AB to R such that f of A is less than 0 is less than f of B. So by intermediate value property, there should exist some x naught in AB such that f of x naught is 0. And if so, this is what you want to prove, right? And if this x naught lies in AB, that means this x naught is a real number. Fine. At least you should be expected that you can solve such small problems in exam. Like this can be expected. This type of proofs you have to solve in exam. Always straightforward questions will not be asked. At least make your situation in such a way so that you can apply such theorems. But to apply these theorems, you need to understand what they are asking in question graphically. If you'll make a graph and you will understand that what they are asking, then the answer is just in front of you on the graph. Because it's so natural, right? That if you have a point on the below of x-axis and if you have a point on the above of x-axis, and it's a continuous function, so it has to cut x-axis, right? Otherwise it cannot reach to the above point. So these exercises are obvious statements, but you need to prove it. Fine, so let's move ahead. 18.9, which says that if you have a polynomial, suppose you have a polynomial function of odd degree. A polynomial function of odd degree has at least one real root. So, is the statement clear? What you want to prove? Any polynomial function of odd degree, that means any function which is of this form, a0 plus a1x plus an xn, where all these ai's are real numbers and n is odd. So then f has a real root. Real root means there exists some x naught belonging to reals such that f of x naught is 0. Fine. This is the meaning of this exercise. That if you have any odd degree polynomial, it should have a real root. So now, what should be your guess? Like, isn't it the statement is pretty natural? If you have any cubic polynomial, it should have a real root. So can anybody give me an intuitive answer? Why is it so? Why an odd degree function should always have one real root? At least one real root. All of them can be real, some of them can be real, but at least one of them will be real.
Yeah, like
Why is it so?
the graphs of cubic polynomials do go like that, right? Like they intersect the axis.
Yeah, so you are saying that graph of x cubes are of this form.
Yeah.
But then that is the question. So this is the question that I'm asking. Why the odd degree polynomial always cut the real axis? Why is it so that it has something upward and something downward? And see, the odd degree is important. It happens only in the odd degree case, odd degree polynomial. So suppose if you take a even degree thing, suppose x square plus 1, fine. Is it have a real root? What are the roots of this function?
Doesn't have a real
What are the zeros of this polynomial?
minus I and I.
Plus minus? Yeah, so plus minus iota are the roots, right? So these are the two roots and none of them is real. So this statement cannot hold for even thing, even degree polynomial. Fine, you already have a counter example. That's why they have given for odd degree. For even degree, it is not true. For even degree polynomials, this result does not hold. Because it is possible that it cannot have any real root. But what happens to the odd degree? Like, what is a special thing about odd degree that it always cuts the x-axis?
Like
If it is a continuous,
f of minus x is not equal to f
what
of x.
Rajni?
Like f of minus x is not equal to f of x. Like it can be f of minus x equals minus f of x or something like that.
But if f of minus x is minus f of x, what happens? Like, why is it a problematic issue?
Like in such a case, the y-axis.
What goes wrong for the odd degree?
Yeah,
Like, what is so special about odd degree that this result holds?
yeah, like because the odd degree, like if we replace it with some f of x, then it goes into negative y-axis. So
No, but you can have functions like this, right? So suppose x cube plus 1, what goes wrong? Like f of minus x is minus. What goes wrong? This is not an answer. Anybody knows the answer? Why odd degree always have one real root? You have done complex numbers, right? In your 11th and 12th. Answer lies there, the chapter of complex numbers. What is so special about complex roots? What is so special about complex roots? Think on that line.
Is it related to that like omega plus omega square plus 1 is
Omega square?
like the cube root of unity, something is there in complex number?
No. So here we are not talking about just 3 degree, right? We are talking about any odd degree. See, the property that complex roots hold is complex roots always occur in pairs. If a plus iota b is a root, then a minus iota b is also a root. Is also a root of polynomial. It cannot happen that just this one is a root of the function and this is not a root. No, complex roots always occurs in conjugate pairs. Right? You can see in this function. So the roots are plus minus iota. Iota is not just a root. Plus minus iota, both of them are roots. So complex roots always occur in conjugate pairs. So if one of them is a root, the other one is also a root. So that means complex roots are always like occurs in even numbers. But the degree of the polynomial is odd, right? Right? The degree of the polynomial is odd and it can have at most how many roots? The degree n, right? N is odd and complex roots always occur in pairs. So one root has to be real number, right? Is the argument clear what I'm trying to say?
Yes, it's clear.
Yes.
Your function, so suppose this is x cube plus x square plus x plus 1. This is a 3-degree function, 3-degree polynomial. So it has, so in complex number it has exactly 3 roots. Right? It has exactly 3 roots, but the complex root always occur in pairs. If a plus iota b is a root, a minus iota by b is also a root. But then there is just one place which is left. And if some complex number c plus iota d is a root, so c minus iota d has to be a root. But it can have at the most 3 roots. So this cannot happen. This situation cannot happen. So the one place which is left should go for the real numbers. There has to be a real number which should lie here, because complex roots always occur in conjugate pairs. That's the answer. That's the special property of the complex roots. Fine. So now is the statement clear what they are trying to say? That why even such a result holds, that odd degree polynomial has at least one real root. So complex roots always occurs in pair, but degree of f is odd. So one root has to be real. So now by intuition the meaning is clear, that why such a statement should be there. Right? Now the main thing is to prove, how to prove such a statement. By geometrically you can see that, yeah, odd degree it should have some real root. But what should be the proof? Mathematical proof. Because you cannot prove that complex root always occur in pair. That's not the proof. It's just an observation that complex root always occurs in pairs. And even you are doing real analysis, so you cannot talk about complex numbers. So now what should be the proof which is fully dependent on real numbers?
So can we like use the previous sum, the idea of the previous sum in this, where f of a, f of b is less than 0?
Okay, so
So we will
if
have
you
to,
use
yes, we will have to
yes,
find some numbers that is f of a is greater than 0 and b is less than 0.
yes, that is the intuitive idea, that find some numbers for which one of them is positive and one of them is negative, so then there should exist a real root lying between them. Okay, that is the like intuitive idea for doing this problem, but writing in a proper way would be like something else. So this is your polynomial, but at least like I'm happy that you got the idea at least. So this is your polynomial, odd degree polynomial. Here n is odd. Now I can assume my a and b 1. Why is it so? I can assume this polynomial to be, such polynomials are called monic polynomials. I can assume that a n is 1. Why is it so?
Divya Didi, your voice got cut
Because
in
if
between.
f has a root, I can divide it by 1 upon a n, because the degree. So now is it audible?
Yeah, now it's say, but after that a n equal to 1, you said something, no? That it's
Is it audible now?
something. Yeah, it's audible.
Okay. See, we can assume that a n is 1. Why is it so? We know that a n is non-zero because it's an odd degree. We first have to fix the degree of the polynomial. Then we'll prove the thing. So if we want to fix the degree to be n, the last coefficient has to be non-zero. But I can assume that the last coefficient is 1. Why is it so? Because I can divide the polynomial by 1 upon a n because it's a non-zero term. And if I'll prove that f of x naught is 0, so 1 upon a n f of x naught is also 0, right? If this polynomial has a root, real root, so this polynomial also has a real root, right? So that's why I can assume that my last coefficient is 1, because I can really divide it by 1 upon a n. Maybe I write it in bracket here, that if 1 upon a n f of x naught is 0, then f of x naught is also 0. Fine. Now this polynomial where the last coefficient is 1, these are known as monic polynomials. Later on you'll study such type of polynomials. And f of x is less than 0 for some x belong to R. Right? Because if this thing holds true, then by previous exercise, we know that if this thing holds true, then there exists an x naught such that f of x naught is 0. There exists a real root. So by previous exercise, it's done. Because there's no previous exercise in exam. Yes, Rajni?
You are not audible sometimes. Like when you introduced f of x not equals to 0, after that you were not audible.
Okay, so maybe I'll change my connection. Like the CMI Wi-Fi is not working. Maybe I'll change the connection. Like I'll use my mobile hotspot. Just give me 1 second. Or voice is clear.
Yes, now it is clear.
Fine. The CMI Wi-Fi is really bad. Okay, so the only thing we need to prove here is that f of x is greater than 0 for some x and f of x is less than 0 for some x. Right? Then by previous exercise, we know that there exists some x naught lying between some a and b. Suppose this is a and this is b. Lying between some a and b such that f of x naught is 0. So I was saying that don't write by previous exercise. You also have to prove the previous exercise that if f of a is greater than 0 and f of b is less than 0, by intermediate value theorem we get this thing. Don't write that by previous exercise because there is no such previous exercise in exam. Fine. So now the only thing is to prove these two equations. That f of a is greater than 0 for some a belonging to R and f of b is less than 0 for some b belonging to R. Then it has a real root. Fine. So how will we prove such a thing that something is greater than 0 and something is less than 0? How will we prove this thing? Intuitive idea is, I'll write down the intuitive idea, but then you will tell me how to formalize each and everything. Your polynomial is this thing, x raised to power n. And it's an odd degree polynomial. That is really important that n is odd. Now, if I take limit x tends to plus infinity, fine. If x is tending to plus infinity, everybody knows how to take this limit, right? X tending to plus infinity. That means you are moving your x's towards infinity. So now you want to see what happened to your fx. X is going to plus infinity. You want to see what happens to fx. So now tell me what happens to fx. If x tends to plus infinity, so it should be
Then fx tends to plus infinity.
yes. This has to be plus infinity, right? If a polynomial is of this form x cube plus x square plus 1, as x tends to plus infinity, fx will tend to plus infinity, right? Because it's an odd degree. But if x tends to minus infinity, what will happen? If x tends to minus infinity, what will happen? Since the degree is odd, make use of that. It's an odd degree. So if you put any negative number,
fx will also be infinity. Like
plus or minus,
minus infinity.
yeah, because if you put any negative number and it's an odd degree, your each and every term will be like, it will tend to, because this is the highest power. If it is going to minus infinity, it doesn't matter what where other terms are going. This is the highest power. You just have to check this thing. Why it is just sufficient to check this highest degree? Because you can really make xn common out, and then it becomes right. And now limit x tends to minus infinity. All of these things will be just, limit will be 1, right? But here the limit is, it's an odd degree. Limit is minus infinity. And it's a bounded thing, so this should tend to minus infinity. Fine. This is how I'm computing the limit. That's why the highest degree just matters. Fine. This is an intuitive idea. So now if your function as x tends to plus infinity, your function goes to infinity, and as x tends to minus infinity, your continuous function goes to minus infinity. So that means there has to be a point whose functional value is positive, and there has to be a point whose functional value is negative. Right?
Yes.
There exists some a belonging to R, a and b, such that f of a is greater than 0 and f of b is less than 0. I have precisely proved the existence, that there should exist, because if none of such numbers will exist, your limit will not tend to plus infinity, and limit will not tend to minus infinity. Right? Because the graph of the function is like this.
But how do we make this statement? Like,
You want to make it
There it-
precise, right? Precise mathematical statement.
yes.
So the precise statement is, do the calculations. Write your function in this form, a naught upon x raised to power n. So see, in exam, if you just write this intuitive idea, that is also fine. It's not like, because it's a clear-cut calculations. You have done each and everything, that limit is going to plus infinity, limit is going to minus infinity. So there should exist points. But still, if you want to do full calculation, like want to write a full proof, so this will be like somewhat calculation will be involved here. Then write your function in this form. Okay, write your function in this form, and then find an appropriate number c. So I'll give you the number because I've calculated it. This is your number. So if mod of x is greater than c, then your functional value not functional value, then this value, a naught plus a1x plus an minus 1 x n minus 1, this mod will be less than equal to, and if x mod basically this. So then your functional value is greater than 0. if x mod is greater than c. And similarly, you can construct the next case, x mod is less than c happen, and then f of x is less than 0.
Can you explain this part to me?
Yes, I'll explain you what is happening here. See, you write your function in this way. It's clear, right? Now, I have chosen a number in a very fancy way such that if your x mod is greater than c, if your modulus of x, like, so suppose this is c and this is minus c. So if your x is greater than, if mod x is greater than c, then this number a0 plus a1x, all of them is less than x mod raised to power n. Why is it so? Because it's actually, what is happening is your functional value is, so now you have written down your a0 plus a1x plus an x minus 1. The main thing which matters here is this highest degree. The other part will be less than this highest degree. I guess n minus 1 times. Right? If your modulus is greater than some number c, that means a0 is than x raised to power n, a1x, so suppose this is a0, and a1x is less than a1x raised to power n, and so an minus 1, n minus 1, this mod is less than an minus 1, xn, right? And xn is less than xn. And now you are just adding up all the terms. This will give you your function f will be less than a0 plus a1 plus an minus 1 plus 1 x raised to power n, right? Your functional value is less than this cx raised to power n. And now your function is, oh, this is your second case. Second case. Now if you consider your x to be less than c, and c is less than 0, so this will be less than 0. So basically, like, you just have to make it more precise. You are constructing an artificial number, this c, such that whenever your x values is greater than c, your functional value will become positive, and whenever your x mod is less than c, your functional value will become negative. Try to do this calculation, how I am getting at this number, why we are using this number. Try to get this calculation, you'll get this result. But the main idea is this thing, that there would exist some numbers. Existence part is okay, but when you actually try to construct the number, it will be difficult. Like, it is not easy to think about this number. See. Fine, but the actual idea is this thing, that there would exist some numbers. This is just an optional part if you want to do it. But at least if you'll write this much stuff, it is okay. Anyone can understand, because this part is not easy to calculate. Fine. At least you got an idea how to solve the problem. I have even given you a number, how to proceed, how to construct this thing. Put condition on your x, you will get the answer. Fine, so let's not waste more time on this problem. At least the idea is clear, Jishnu?
Somewhat, yes.
See, if you look at just my calculation, it will not be clear to you. You really have to like make your hand dirty and do the calculation. How applying this condition will give you f of x greater than 0, and how applying this condition will give you f of x less than 0. So that means 0 is lying between them, and then apply the intermediate. And why this number c occurs, we'll understand if you'll do the calculation like by just sitting down and then solving it properly. Okay, so let's start with the problem set of exercise 17. Exercise 17s are really easy. Now we'll solve easy problems, because now you don't have to apply all these theorems, intermediate value or partial converse. You will just require the definition of continuity and algebra of continuous function. The difficult part I've already done. And in the next class, someone will please present problem 18.10. I am not assigning this problem to anyone, but try this problem out and please someone present this problem. I want that someone solve this problem 18.10. I don't want to like forcibly tell you that you have to particularly solve the problem. Anyone who will solve this problem can present it in the next class 18.10. So this is an homework exercise. Hint is given to you at the end of the book. If you want to discuss with me, you can message me. But at least someone should volunteer for this for the next class. Not right now. Try out this problem on your own and then present it. Okay. So let's start with the exercises of 17 section. Oh, before starting the 17 section, can anyone just tell me whatever is being covered in the class till now? Which section he started? Uniform continuity or the next section?
We did today the proof of intermediate value theorem and some of these like questions which we discussed
He has,
today.
but I guess I was talking to some student. They were saying that this like limit of continuous function has been started the 20th section.
No, I don't think so. Like we did this portion like the proof which we did just now, and also we did the proof for intermediate value theorem.
Okay. Okay, so then maybe in the next class I can discuss homework 5 problems, all homework 5 problems, and then I can start with the new topic, whatever he will start. Homework 5 or homework 6, whatever it is. Like the homework based on continuity problems. Okay, so let's start with 17 section. 17 sections back exercise are easy ones. Let's see how much you know about. Just here you just have to apply continuous function and algebra of continuous function and sequential criterion. These three things will be required to solve exercise 17. So first of all, suppose you know that, so suppose you are aware that this sine function, all trigonometric functions and then log x and then exponential, all of them are continuous. I am assuming this thing right now. And now if you want to solve this problem, Can you solve such problems A, B, C by just applying algebra of continuous function and composition of two continuous function is continuous? Composition of
It's
continuous function,
yes.
right? Because for the first problem, you can see that cos x is continuous. So power of the cos x should also be continuous by product of continuous function. So 1 plus cos x should also be continuous. And then log of this thing should also be continuous by composition. Maybe I'll write down one thing. So your function cos x is continuous. So therefore, taking power 4 times should also be continuous. This is just product of two continuous functions. And then 1 plus this thing is continuous, sum of two continuous function, and then composition. This is continuous, log x is continuous, so composition should also be continuous. So by algebra of continuous function, you can solve such type of problems by starting it from very scratch. That here you will require that sin x is continuous, cos x is continuous, powers are continuous, sum is continuous, therefore power of this is also continuous. Fine. Let's just move to some other problem. It says that square root x is continuous function on 0 to infinity. How to proceed for this? Sequential criterion or epsilon delta definition? What do you want?
Epsilon delta definition.
Okay, so let's start with epsilon delta definition. Let epsilon greater than 0 be given. And what do you want? You want to construct some delta. There exists some delta. So you want to construct this delta such that whenever x minus x naught is less than delta, this implies f of x minus f of x naught should be less than epsilon. Fine. This is what you want to prove. So now let's see how to construct this delta and consider some point between 0 to infinity. Fine. Why the domain is 0 to infinity? Why negative numbers are not involved here?
It would be complex.
Yes. Otherwise, you'll go to the complex numbers because square root of negative numbers will just create iota. So to be in real numbers, that's why we have put the restriction on domain. Everything is important. Like while solving a problem, notice each and everything why this condition has to be given. Fine. So let epsilon greater than 0 be given and then consider f of x minus f of x naught. And we'll create a delta with this thing. So square root x minus square root x naught. Now what? Which step I can do now? How I'll create my delta now? Somebody should answer. What should be the next step?
Rationalization.
Yes, so rationalize it and you will have x minus x naught upon square root x plus square root x naught. Fine, because anyway you want to reach this step so that you can create your delta. You want to reach at x minus x naught. Your main goal is to reach x minus x naught by somehow so that you can create your delta. So now you have reached x minus x naught, but some extra term is also coming. I am not putting mod because all of them are positive. What I'll do for this extra term? I can't make it less than epsilon because here x is also there. and delta cannot be dependent on x. It has to be independent of x. Fine. I cannot write my delta to be epsilon of square root x plus square root x naught. No, this cannot happen. Whenever there is x, you cannot write your delta because this x is a variable and it keeps on changing, and you want your delta to be a fixed quantity. So this is completely wrong. If you'll write your delta in terms of x, this is completely wrong. You'll not get any marks for it. You have to create such delta which does not involve any x. X naught is fine. X naught is a fixed real number, but x is a variable. Then what should I, like, how should I proceed here?
We can use the fact that 1 by root of x naught is less than 1 by root of x plus 1 plus root of x naught.
Yes. Yes, that's the answer. Just 1 second. So now, what do you have is, this thing is less than x minus x naught mod upon square root x naught. Right? I'm removing some quantity, positive quantity from here. So I'll get a bigger number. Fine. Now there is no x here. I can safely make it less than epsilon. This is less than epsilon if x minus x naught is less than square root x naught epsilon. And now I can choose my delta to be square root x naught epsilon. Now delta is not dependent on x. X is not here. So this will imply x minus x naught mod less than delta imply f of x minus f of x naught is less than epsilon. So this implies f of x, which is square root x, is continuous everywhere on 0 to infinity, because your x naught was an arbitrary point. If you have shown the continuity on arbitrary point, it is continuous everywhere. Is the proof okay? Is there any doubt in the proof? Any step which is not clear? So now if your function is x raised to power n, how will you prove continuity? F is continuous. Which is easy way of proving the continuity of this function? Is it a sequential criterion or by epsilon delta definition?
Can we not use the algebra of limits, because since f of x is equal to x is continuous?
No, we'll not use the algebra of limits here. I am asking which method is convenient. I am going by definition, whether sequential criterion or epsilon delta.
Okay.
So in exam, you really have to make a choice whether you want to prove it by epsilon delta definition or by sequential criterion, and then you have to save your time. If you start proving it by epsilon delta definition, then you really require to solve this thing. And those who don't know the binomial thing, they cannot solve it, because here you will require the binomial formula, that this will look like x minus x naught and then some power of this, such type of formula. There you really require such thing. If you don't know this stuff, then don't go for epsilon delta definition. Fine, and then you have to remove this term also by making it less than, by choosing your x minus x naught to be less than 1 and taking the minimum thing. So then it's better to go for sequential criterion, because here we'll have a lot of complexity. So let's go for sequential criterion. Make use of your sequence knowledge. So for sequential criterion, you require that whenever any sequence converging to x naught, your f of xn should converge to f of x naught, then f is continuous. Right? This was your sequential criterion. So let's start with any sequence. Let xn be a sequence such that xn converges to x naught. Fine, xn converges to x naught. Now what? What about xn raised to power n? What about this sequence? When xn converges to x naught, xn raised to power, so I'll not say xn, maybe say, because there is a lot of n here, let's say xm. If xm converges to x naught, xm raised to power n converges to x naught raised to power n, right, by algebra of sequences. Right? Product of two sequences converges to the product of the limits, right? So now your f of xm converges to f of x naught. So therefore f is continuous function. If anybody is interested in knowing epsilon delta definition, by using epsilon delta definition, you can message me on my number. I'll provide you the solution for epsilon delta definition also. But there the proof will be quite a bit long. That's why I don't want to prove it here. There you require some manipulations. So if you can prove it in just 1 or 2 lines, then there's no need for doing epsilon delta definition. But yeah, if anybody is interested in knowing the idea, how should we proceed by epsilon delta definition, then you can contact me. So now, if this function is continuous, what do you have as a result? That every polynomial function is continuous. Why? Because every polynomial function is of a0 plus a1x plus an xn, right? Each of them is continuous. So the sum has to be continuous, right? By algebra of continuous function. And if each of them is continuous, so you have that rational functions are also continuous. What do you mean by rational function? Rational function means the functions which are of the form fx by gx, where gx is non-zero for all x belongs to domain. Fine, such type of function is also continuous by algebra of continuous function. Is the argument clear why all type of these functions are continuous?
Yes, ma'am.
Right? So now let's just see why mod function is continuous. This I have already given the proof in class. Why mod x is continuous. apply the theorem. Consider your function fx to be x. This is continuous. You can easily prove it to be continuous by choosing your delta is same as epsilon. Identity function is continuous. So then I have already proved in class that mod function is also continuous. If f is continuous, mod f is continuous. So now what is your mod f? I have already proved that if f is continuous, mod function is continuous. If you want to write down not just in one line, write down the proof of that theorem. That if f is continuous, mod f is continuous. And then write it. If this question is of like 4 to 5 minutes. Now comes the real idea. So now suppose you want to prove that if your function is continuous by epsilon delta definition. Now what will you do? You don't have sequential criterion now. So then there is a standard technique which is always used to prove the continuity of the functions. So whenever you have sequences and you have two equations, how will you combine the information of the two equations for sequences? By taking, how will you choose your k in case of sequences?
The maximum.
Suppose one yeah, by taking the maximum trick, right? By taking the maximum of n1 and n2. So now in continuity, you will also have a standard technique which will always be used while proving it by epsilon delta definition if you are not able to get rid of x. Fine. If you want to eliminate your x at the end, there is a standard technique. So just see the proof and try to use that standard technique everywhere. I'll prove this thing in very detailed way and by using epsilon delta definition. So now suppose I want to prove the continuity at 4. Fine. Because you first have to fix a point on which you are checking your continuity. So suppose this is the point where you want to check your continuity. 4 or 2, anything. Let's make it 2. So now let epsilon greater than 0 be given and f of x minus f of 2. This is just a number I am taking. You can even take arbitrary x naught. You can prove it for arbitrary x naught. Just replace this 2 by arbitrary x naught. It doesn't matter. The proof will remain same. Now you have x square minus 4. Now what? I just have x minus 2 and x plus 2. Fine. I have the quantity x minus 2, but along with the I have this number also, and it is dependent on x. How I'll get rid of this x? Anybody having any idea how I can get rid of this x in this equation? Here you cannot make it less than epsilon, right? Because this will be less than epsilon if x minus 2 is less than epsilon by x plus 2. And you cannot choose your delta to be this. No, it is dependent on x. I am warning you many times. Don't choose your delta which involve x. Always choose your delta which is a real number, not variable. It's a variable quantity. So I cannot make it less than epsilon right now. I have to do some manipulation. Now what? very standard first problem for the continuity. If anybody has started studying continuity, the first problem you want to solve is this problem, right? By epsilon delta definition. Somebody should answer. What technique should I use to get rid of x? That means you haven't started solving problems for continuity. That is pretty clear. You have not started solving problems for continuity. Because if you have started solving problems for continuity, this is the first problem you want to, first non-trivial type of problem which you want to solve using epsilon delta definition. So suppose so this is the trick which I'll use here, and try to invoke this trick whenever you are stuck with the x. So suppose I'll assume that x minus 2 is less than 1. Fine. If x minus 2 is less than 1, I'll apply my triangle inequality. Right? So the next mod is less than 3, right? Right? Or I should write it more clearly. That this is less than x minus 2 mod, and then this is less than 1. And then this mod opens, so it is less than 3. Is this step clear? Mod x is less than 3.
Yes, it's clear.
Nikita, is it clear? Is this step clear? Fine. I just have opened this mod. It's lying between 1 minus 2 and 1 plus minus 2. 1 second. What is this? Sorry. This is minus 2 minus this thing, and then 1. Fine. L minus epsilon and L plus epsilon. Fine. So this is less than minus 3. Now what? You were stuck at this problem, right? Now your problem will be solved. X minus 2 mod and x plus 2 mod. You can write it less than x mod plus 2, right? By triangle inequality. And x mod is less than 3. So you have 5 here. Which is less than epsilon if x minus 2 mod is less than epsilon by 5. Now what should I do? What should be the value of delta I should choose here? Can somebody wants to answer what should be the delta?
Epsilon by 5.
No, delta is not epsilon by 5. Because you are getting it less than epsilon by 5 after assuming that this thing is less than 1. If you choose your delta to be epsilon by 5, whenever x minus 2 is less than 1, then only this will happen. You have make a choice here.
So we can choose epsilon, delta as 1.
So minimum of this thing. So suppose it is epsilon by 5 is less than 1. Then what? So minimum of 1 and epsilon by 5. Fine. Why is it so? So suppose minimum is 1. Minimum of 1 and epsilon by 5 is 1. That means x minus 2 mod is less than 1, right? This will imply your result. F of x, this thing is f of x minus f of x naught is less than epsilon. And minimum is, suppose minimum is epsilon by 5. So then x minus 2 less than epsilon by 5. If minimum is epsilon by 5, that means 1 is bigger than this quantity. That means it's already less than 1. Then also you'll get the result, right? In both the situations, you'll get the result. That's why you have chosen your delta to be the minimum of 1 and epsilon by 5. Whichever quantity is small. Fine. In which proof I have already applied this technique. I have used this technique once in some of the proofs. Deep, do you remember in which proof I have used this technique?
I think it was that. Wait, 1 second.
The proof you asked today. Why
That
we have chosen
theorem.
delta to be minimum? Why we have chosen delta to be minimum of this? Right? There we also use this technique. So whenever you have this x coming out here, you can get rid of this thing by taking your x minus x naught mod is less than 1, get the result, and then choose your delta to be 1 and whatever you get in terms of epsilon. This is the very standard technique which will always be used using if you want to apply epsilon delta definition and you want to get rid of x. It's a very standard technique. Just like you're taking maximum of n1 and n2. Fine. So now your x minus 2 mod less than delta will imply is less than epsilon. Is the proof clear? Why x square is a continuous function? It's a very nice proof and you have to like be comfortable with these techniques.
Could you like explain this thing again? Like, if we want to remove x, then why are we just removing the x plus 2 thing? Why not the x minus 2 also?
Because in the definition you require that you want to construct delta, right? Delta consists of x minus x naught should be less than delta. So why will you remove x minus 2? You want this thing here.
Acha,
Right?
okay.
The definition says f of x minus f of x naught is less than epsilon whenever x minus x naught is less than delta. So why will you always want this thing to construct your delta? So why will you remove this part? You'll always remove this part, right? Whatever is the extra part.
Okay.
Fine. You always choose to remove the extra part, not whatever you are required to prove the definition. This was the extra part, x plus 2 was the extra part. If I have got 5 times x minus 2 after doing the calculation, I can just straightforward take it less than epsilon and then x minus x2 is less than epsilon by 5 and I can choose my delta to be epsilon by 5. My life would be very simple if it's already a real number, right? But it is dependent on variable. The extra part is dependent on variable. That's why I have to make these manipulations. Fine. Now what about this function? Now you have become familiar with the technique. What about this function? X sine 1 by x. If x is non-zero and 0 if x is 0. How to write the proof for this function? Continuity proof by epsilon.
This
delta
one I
definition.
think we've done already.
No. This is continuous at 0. There we proved it is discontinuous. The function was not same. So that involved some root x. I guess sine 1 upon root x. There was nothing here, I guess. Or I guess if it was here, it is something else. This is not. This function is continuous at 0.
Yeah, it was sine 1 by x square.
Yeah. Here it is continuous. F is continuous at 0. Fine. You can check the limit at 0. Left hand limit matches with the right hand limit matches with 0. But now you want to prove it by epsilon delta definition. So let epsilon greater than 0, f of x minus 0, because 0 is the only problematic point, right? If I'll remove 0, then it's continuous. It's defined everywhere. Trigonometric is continuous. By algebra of continuous function, it's continuous at other points. The only problematic point is 0, because the function is breaking at 0. So we'll check the continuity at 0. This is x sine 1 by x mod. Now what? You have mod x and sine 1 by x. Now what? How can the extra part is dependent on x. How I can remove this extra part? What should be the idea? How I can remove this extra part?
By saying that it lies between -1 to 1.
No, so this technique will not be applied, because here you are not just having x, you are having trigonometric function. Make use of trigonometric function. Apply your 11th, 12th class knowledge. What is so special about trigonometric function? Someone should say the answer here. This is so easy. You have done such arguments before in sequences.
Their range.
Yes,
Their range of values.
they are.
Range of values.
Range, yeah. So it can be at most 1, right? So it is less than mod x, right? Right? You got your x minus 0 mod, which is less than epsilon. So now choose your delta to be epsilon. There's no technique, no special technique that was required in this question. Now the last question, I'll do the one last question and then rest of them I'll do in the next class. Suppose your function is now fx equal to x cube. You have solved the second degree. What about third degree? F of x minus f of x naught. This is x cube minus x naught cube. And what is this? Everybody knows this identity, right? X cube minus a cube minus b cube. Is there anyone who don't know this identity, AQ minus BQ formula, which is A minus B, A square plus B square plus AB? Now what? Now how can you get rid of this extra part? Now there is no trigonometric function, no special function, it's just involving x. Now how can I get rid of extra part? Same technique will be applied, right? There you just have x square. Now you have, there you just have x plus something, right? X plus 2. Now you have x square plus x not square. So the degree just has been changed. It's again a polynomial, right? Same technique will be applied. If x minus x naught mod is less than 1, then what? Your x mod is less than x mod is less than,
X naught plus 1. But
yeah, x naught mod plus 1. And then apply this technique. Which is less than equal to, by triangle inequality, it is less than equal to x mod square, x naught square plus x mod x naught. Fine. And now you know that x mod is less than x naught mod plus 1 whole square. Right? This is a very huge number, but it's just a real number, right? After solving, suppose I'm choosing this number to be A. Okay, I'm giving a name to this number. This is A, right? Which is less than epsilon if x minus x naught is less than epsilon by A. But it's a real number, there is no x here. So now, what should be my delta? Choose delta to be, what should be delta?
that minimum thing.
The minimum.
Yes, minimum of 1 and epsilon by A. Fine. So then x minus x naught mod less than delta will imply, see, we are not doing any magic here. These are all the manipulations, these are all the tricks which has been made to solve such problems. And they have prepared it very logically. It's not like they already knew the answer. They have made such type of tricks. Like they have spent their time and made such things so that you can solve such problems. Otherwise, it's very difficult to get rid of this extra part, right? Every time get rid of this extra part. Because there can be many complicated type of polynomials. But you can really found a bound on this x. It's like creating a bound for x. Fine. Is the argument clear? Such type of proofs you need to write in your exam. Some complicated extra term will be there. You have to get rid of those complicated extra terms. If it is a polynomial term, this is the technique to get rid of it. If it is trigonometry, apply your bounded theory that trigonometric functions are bounded. Some trick needs to be applied to get rid of extra part and make it less than epsilon. But don't choose your delta to be dependent on some x, or it's like x times epsilon. No, these are completely wrong notations. Delta cannot be a variable, it has to be a real number. Fine. I'm just warning you because I know that many students will commit this mistake. Choosing your delta, whatever extra part is here, just make it less than epsilon and putting it in the denominator. No, because this extra part can be 0 also. Here it can't be 0. Right? Don't commit such type of mistake. At least remember this point, that don't make your delta dependent on x. Delta should not be a variable, it should be a real number. Fine, I'll send you the notes by tomorrow night. If I'll not send the notes, just someone remind me, because last time Rajneel reminded me of sending the notes, because there are so many things going on here and like I can forget. So someone please remind me if I'll not send it today. Practice all such exercises, all the things, all back exercises. Try to solve as many questions as you can, because this time we are really very slow. This time we are not in any rush. You have a lot of time before having mid-sem. When is your mid-sem? Is the date sheet out?
Next Wednesday.
This Wednesday?
Next.
Next
6th,
Wednesday, right?
6th July.
So, okay, so you are having this week to study. And the main part is this series thing. I have done almost all the questions of series. And then this 17th section, which is just continuous and algebra of continuous function. And then this 18th section, which is properties of continuous function. All your theorems. Fine. These 3 are the important topics of your mid-sem. At least be very prepared with these 3 topics. Don't be very don't do the mid-sem like your first mid-sem. Be very serious for second mid-sem, because after that you will just be having your end sem. There is no more chances. And the syllabus is quite less for this mid-sem. After that you will be having derivations and then Riemann integration. And these are the 2 difficult topics, most difficult topics for the syllabus. Continuity is very easy. Just try to be comfortable with continuity. Fine. So next week we'll finish this 17
Excuse me,
section.
ma'am.
Yes.
In this, we are specifically taking this x minus x naught to be less than 1. So aren't we like specifying one particular condition when this is happening? And
Yeah, so that's why we are manipulating our delta to be minimum of this. Right? Because we want to see what happens in the neighborhood of x. We are interested in what happens when we are very close to x. That's why we are putting this condition. We really don't care what happens in this area and this area. We want to see what happens when we are very close to x. Close to x naught, sorry.
okay.
So it's like we are taking x naught minus 1 and x naught plus 1. So we are interested in what happens in this neighborhood.